So fractiles are numbers that partition or divide an ordered data set into equal parts. So the thing to notice, you have to order the data first. So you have to put the data into numerical order, but then we're just going to cut it into equal pieces, and that's what fractiles do. So for us, we're going to focus on a special type of fractile called the quartiles. And so with the quartiles, we're dividing an ordered data set into 4 equal parts. So think of quartiles as dividing your data into quarters, right? So you're cutting it into 4 equal pieces. So think of it like a Hershey bar, where you're going to share your Hershey bar among 3 other friends. That's what our quartiles do. We divide our data set into 4 equal pieces. So we have 3 quartiles. So the first quartile is going to be a position where about 1/4 of our data will fall at or below Q1. So a quarter of our data is there. So on this Hershey bar I drew, quartile 1 or Q1 is going to be that first break in the candy bar. The second quartile, you have half of your data at or below the position. So Q2 is your median. So we've already talked about one of these quartiles before. We've talked about how to find the median. And then the third quartile, 3/4 of your data fall at or below Q3. So Q3 would be that third break in our candy bar. The good news is, if you can find the median, you can find the other 2 quartiles, Q1 and Q3. The process for finding them is virtually the same. So let's look at a data set and see how we would find the quartiles for this data set. So here we have the number of nuclear power plants in the top 15 nuclear power producing countries in the world. And so we want to find those 3 quartiles of our data set. So what are those 3 numbers in our ordered data set that splits our data, where we have 1/4 of the data below the first value, half of the data below the second value, and 3/4 of the data at or below the third value? So the first thing we need to do is put this data into order. So 6 is my smallest data value, 7, 8, 10, 11, 15, 17, 18, 18, 19, 20, 31, 54, 59, and 104. So we have that data in order of all 15 nuclear power producing countries, the number of nuclear power plants. So to find these 3 quartiles, you want to start out finding the middle quartile first. So find Q2 first. So let's stick with what we know, right? We know how to find Q2. So remember from section 3.1, to find Q2, the location of Q2, the location of the median, is n plus 1 over 2. So in this case, we have 15 data values. So 15 plus 1 divided by 2 tells us the 8th position is our median. So we go in 1, 2, 3, 4, 5, 6, 7, 8. So 18, that is our median. That is Q2. So half of our data lies at or below 18 in this case. So then from there, what that median does, your median is dividing your data set into 2 different halves. So you have the lower half of your data and your upper half of your data. And so from here, what that means, your median is not going to be in either half of your data. So think of your median as a fence or as a wall. That fence is not in either yard, or that wall is not in either of the 2 rooms that are on either side of it. It's there as a divider. So their median acts as a divider. It's not a part of either half of the data set. And so if you had an even number of data values, then your median is still going to be in between two data values. So the two data values would be in the respective half, but the median would not lie in either half. So that median itself is still the fence dividing your data into two equal halves. From there, to find the first quartile, you just find the median of the lower half of data. So here now in our lower half we have 7 data values. So the location of Q1 out of those 7 data values would be 7 plus 1 over 2, so 8 over 2, which is 4. So our fourth data value in that lower half of data is the first quartile. And similarly, the fourth, since we know we split them into two equal halves, we have 7 in the upper half also. So our fourth data value in the upper half of our data is Q3, the upper quartile. From here, the next piece of information we get from these quartiles is the interquartile range. So the interquartile range is simply the range of the quartiles. So the interquartile range is the range of the quartiles. So remember, to find the range of a data set, right, it's the largest minus the smallest. So for us, for the interquartile range, it's going to be our largest quartile minus our smallest quartile. So Q3 minus Q1. So if we go back to this data set that we just looked at, and we want to find the interquartile range, we just take our value for Q3, so Q3 minus our value for Q1. So in this case, our interquartile range is going to be 31 minus 10, which is 21. So what this is telling us is the number of power plants in the middle portion of the data set vary by at most 21. So we can put all of this together and we can get a 5-number summary for our data set. So this 5-number summary is simply the minimum, the first quartile, the median, the third quartile, and then the maximum. So if we go back to the same data set again, we take those 3 quartiles and combine it with our minimum and our maximum to get our 5-number summary. So our 5-number summary in this case is going to be our minimum, which is 6, Q1, which is 10, Q2, which is 18, Q3, which is 31, and the maximum, which is 104. So looking at this really helps us to be able to visualize if we have an outlier. In this case, we can kind of tell, okay, our quartiles and our minimum are relatively close, but then that maximum 104 is way out there. And so you can really tell, okay, that maximum is probably an outlier. So you can really start to visualize your data using this. So the other types of fractiles that exist, so deciles divide our data set into 10 equal parts, and percentiles divide the data set into 100 equal parts. So percentiles you're probably familiar with. So if any of you have ever taken any standardized tests, for example, maybe the ACT or the SAT, or even on high school testing, then you typically notice when you get your score report that it's given to you in terms of what percentile that you ranked in, or children's growth. Your children's growth, when you go to the pediatrician, for example, those of you who have kids know what I'm talking about, they tell you what percentile your child ranks in. And so that's what they're talking about, is basically what percent of people would be at or below that level that you were at, or that your child was at. And so the notation we use for these, so we use Q1, Q2, Q3 for quartiles. Similarly, we would use D1, D2 up to D9, or P1, P2 up to P99 for percentiles to talk about deciles and percentiles, respectively.